Okay, so on Monday, you will have quiz number 3. And quiz number 3 is on finding domain. And 2.6, the functions. So the rules for finding the domain is you should always start out by assuming that the domain is all real numbers, except when you have a fraction and when you have a square root. So when you have a fraction, you're going to, like for example, let's just say it's 4 over x plus 4. So when you have a fraction, we can't have the denominator equal to 0. So what we would do is we would set the denominator, whatever expression is there, not equal to 0. Solve for it, and then x could not equal -4. So if you pictured this on a number line, it would be everything except -4. So you would go from -infinity up to the -4, then you have to union that, and then starts again on the other side of -4 and goes to infinity. Notice the parentheses around the -4 indicating that it doesn't include -4. Now, if it were flipped, let's say it was x plus 4 over 4, this one's all real numbers. There's no x to plug in a number for to make that denominator a 0. There's no restriction when the numerator is just an expression. Everybody good there? Now, the other exception when it's not going to be all real numbers is when you have something under a square root. So for example, let's say we have x plus 4 under the radical now. So when it's under a square root, we only want real answers, so we don't want to get an imaginary number. So we're going to set, without the radical, what's underneath there to be greater than or equal to 0. We only want positive answers. So then once I solve this, I get x is greater than -4. And then in interval notation, or if you look at it on your graph, this would have been a closed circle and then all numbers greater. So then it's going to be a bracket around the -4 going to infinity. So that's when it's just a radical. Now, if the radical's in the denominator, then instead of greater than or equal to, it would be, let's say it's the 4 over the x plus 4, but it's under the radical. It can't equal 0, so you just take what's under the radical and make it greater than 0. And then you would solve. And then the only difference with the interval notation there is it's going to be a parentheses instead of a bracket. So those would be the exceptions. If it's a cube root, it's all real numbers, okay? It's only when it's a square root that we have to make sure that we don't get a negative number, because then it would be an imaginary and it wouldn't be a real solution. So this is how you would find domain. These are the rules for domain. We did this back for the chapter 2 test. It wasn't specifically taught to you in 2.6. It was prior knowledge that we had to apply when we did the composite functions. So it was included in 2.6, but officially it was taught to you earlier in the chapter. All right, so let me go ahead and zoom in here, and I'm just going to work them all out. It should be pretty quick. Number 1, it only wants us to find the domain of the given function. So for this one, I've got a radical and I've got a fraction. Now the radical's in the numerator. So when the radical's in the numerator, we're going to set what's underneath here to be greater than or equal to 0. For the denominator check, x plus 4 cannot equal 0. So now I need to solve both of these. My domain is going to be a combination of the two. So once I subtract, x is greater than or equal to -3. subtract 4 here, x cannot equal negative 4. So if it helps you to see it visually on a number line and then turn that number line into interval notation, you can. So over here, I would put negative 4, then negative 3, because if you think about it, this is what the number line looks like. So then my open circle is on the negative 4, because it can't include it, and then a closed circle on negative 3, but all values greater than that. Notice the excluded value isn't going to affect the x is greater than or equal to negative 3. So that's what my domain is. I just take this and I write it in interval notation. So negative 3 with a bracket because it's greater than or equal to infinity. The infinity and the negative infinity always get parentheses. For number 2, this one was similar to what I just showed you when I went over the rules. There is nothing to exclude here. Nothing, there's no x value to plug in a number for, so this is all real numbers. Nothing to exclude from the all real number set. For the next one, nothing to exclude for the numerator. It's not a radical. However, the denominator, I have to set this not equal to 0. So what I'm going to do here is factor it. This will factor into x minus 3, x plus 1. These are going to be my values that x cannot equal once I solve them. So I'll add 3. So x cannot equal positive 3, and x cannot equal negative 1. So again, if it helps you to see the number line, put negative 1 and positive 3 here. So open circles here, but then it's everything else. So where those open circles are, that's where my u's are going to go. So again, my graph has negative infinity here, positive infinity here. So it's going to go from negative infinity up to the negative 1 with the parentheses because it can't include it. Then I'm going to union it. That's the open circle. Start again at negative 1, go to positive 3, union, start up again, and then to infinity. All parentheses. For number 4, it's not a fraction, it's just a radical. So remember, we only want positive values. So 2x minus 3 must be greater than or equal to 0. Add 3. 2x is greater than or equal to 3. Divide by 2. And x is greater than or equal to 3 over 2. So again, on your number line, 3 over 2 is here, which is like 1.5. But it'll be a closed circle going to infinity. So this will be a bracket, 3 over 2 to infinity. The last domain question. Again, I've got a radical and a fraction, so this is similar to number 1. I need to set what's underneath the radical, the numerator, greater than or equal to 0. However, the denominator is set not equal to 0. I'm going to go ahead and solve. I can add x. You could have also subtracted 8. But just remember, whenever you multiply or divide by a negative, you would have had to have switched the symbol. Now, I like to think of this as like a Pac-Man or an alligator. So I'm going to flip it around. So this is really saying x is less than or equal to 8. And then here, add the 10. X cannot equal positive 10. So if I add this to my number line, I have 0, then 8, then 10. So x is going to be less than or equal to 8. So closed circle going here. But the 10 is an open circle. Just like number 1, that open circle doesn't affect the x is less than or equal to 8. So I can go ahead and my domain will only be based off of this. So it's from negative infinity up to the 8 with a bracket, and negative infinity gets a parentheses. Next, we're combining the functions. So remember, whenever it's f of x plus g of x, because really what this means is do f of x function plus the g of x function. So I'm going to take f of x, add it to the g of x. All I'm looking for are like terms to combine. So I just have to do negative 3 plus 1. And honestly, the order that you write these terms doesn't matter. So you could put the x, the constant, and the radical, or you could have put the radical first. It really doesn't matter the order, but just make sure your signs are appropriate and the x is positive, the square root of x is positive, but the 2 is negative. Now, when you subtract the functions, really what we're doing here is f of x minus the g of x function, and you need to distribute the subtraction sign. So really we're doing the f of x function minus the g of x function. So I have to distribute this subtraction sign. So this becomes x minus 3 minus the square root of x minus 1. I combine my like terms, and I get x minus 4 minus the square root of x. Now for the next one, what I wanted you to do here is combine f and g and then plug in 4. I forgot to put parentheses around that. So I'm going to take the answer I got from number 1, and then I'm going to plug in 4 for my x's. That's what it was expecting you to do. So the f of x function plus the g of x function was x minus 2 plus the square root of x. I'm going to replace x with 4 and then simplify. So I get 4 minus 2 plus the square root of 4, 4 minus 2 plus 2, and this ends up giving me 4. The next one wanted you to divide. Again, all you're going to do is place the two functions on top of each other. So I'm going to do x minus 3 over the square root of x plus 1. You don't need to rationalize or anything. You leave it just like that. For the next one, it wants me to plug in a 16 this time. So again, I'm going to take this answer I got from number 6. I'm taking the x minus 2 plus the square root of x. 16 minus 2 plus the square root of x. All right, so then this one, I need to square root the 16. And then I'm going to add straight across. So 16 minus 2 is 14. And then 14 plus 4 gives me 18. Now this one was a little different. What they wanted you to do was take the f of x function and plug in 12. So remember, your f of x function is going to be, so you're going to first do f of 12. So the f of x function was x minus 3. So I'm going to replace x with 12. And then I get f of 12 to be equal to 9. Now I'm going to take that 9 and I'm going to plug it into the g of x function. So now I'm really doing g of 9. And then the g of x function was the square root of x plus 1. So the square root of x, when it's a 9, I get 3 plus 1. And then the g of f of x, when x is 12, is equal to 4. Next one.
Can you keep it the same?
Yep.
Thank you.
All right, number 12. This one, they're asking us to subtract the functions. I could go back, and I already subtracted them in number 7. So I'm going to take number 7's answer, which was x minus 4 minus the square root of x. And then I'm going to plug in negative 2 where I see x. So when I plug in negative 2, and then minus 4 minus the square root of negative 2, this is going to end up giving me negative 6 minus I radical 2. And then the last one wants me to multiply. Now I'm going to show you two ways that you can do this. Let's say they said to do just f of g of x without a 1 there. So what you would have had to have done is taken x minus 3 and then the square root of x plus 1 and FOIL this. So if that were the case, you would get x times the square root of x plus x minus 3 times the square root of x minus 3. Nothing here can be combined, so that would be your final answer here. Now, but the question was, find f of g of 1. Now, you could do this two ways. If they ask you to have combined it, you can take this combined answer now. Every place you see x, put a 1. And I get 1 times the square root of 1, negative 3 times the square root of 1, and then I would get 1 plus 1 minus 3 minus 3, and then I would get 1 plus 1 is 2, minus 3 minus 3, so then negative 1 minus 3, and then I get negative 4. Now, what you could have also done is taken, if you knew that f and a g next to each other like that means to multiply, another way you could have done it is don't FOIL it. At this point, plug in your 1 here for x, which makes the problem a lot simpler, and you do 1 minus 3, the square root of 1 plus 1. This gives you negative 2. This gives you square root of 1 is 1, and then 1 plus 1 is 2. And then negative 2 times positive 2, negative 4. Same answer I got if I had to have plugged it into the combine function. If it's just asking on the quiz to find the value of the multiplication of f of x times g of x when x equals 1, you can do it the other way because it's multiple choice. So for number 13, no, 14, sorry. 14. So be very careful when it's got the little circle. Notice this little circle here. It's not telling you to multiply the functions. It's telling you to take this f of x function, and for its input, you're plugging in the g of x function. So really what we're doing is plugging in x plus 2 under the radical into the f of x function. So remember, your f of x function is the x plus 3. So what I'm doing is replacing x with this radical. So what I'm going to end up getting is going to be x plus 2 under the radical plus 3. Because I took the f of x function, which was x plus 3, and I replaced x with the g of x function.
G of x would be the input function here?
Correct.
So find the domain of that.
You have to find the domain of the input function, correct. All right, so this is the combine function. Now we have to find its domain. So I'm going to go ahead and find the domain just to show you practice of domain. The domain of the f of x function, there's no restrictions. This one would be all real numbers. But we don't need to do this to answer the question. What we need is the input, which was the g of x. This one has a restriction. It's a square root. We take what's under the radical, set it greater than or equal to 0. Subtract 2. X must be greater than or equal to negative 2. So in interval notation, this would be from negative 2 with a bracket to infinity. Now, my combined function, notice the only thing that I would have had to check was my input, because there's nothing to check there. So my domain of the combined function and of the input function is the answer. It's the x is greater than or equal to -2. So in interval notation, bracket -2 to infinity. So this is the combined domain, which is also the domain of the input. Sometimes it ends up being just the input domain. Maybe the combined function won't have any restriction. All right, then 15. Now it's in reverse. This time my input function is the f of x function. So let's go ahead, and now we're taking the f of x function, and it's going in as the input. And the f of x function, remember, was the x plus 3. So I'm taking my g of x function, which is the square root of x plus 2. So I'm going to put x plus 3 plus 2 under the radical. I can combine, and it becomes x plus 5. So this is the combined function. That's what it equals. So now let me find my f of x was my input. So the input domain, remember that was x plus 3. No restrictions. This one's all real numbers. However, my combined function does have a restriction. It's under a radical greater than or equal to 0. Subtract. X must be greater than or equal to -5. So the combined domain is just based on the combination, and that's going to be from -5 with a bracket to infinity. And that is your quiz review.